In this video, we will evaluate a double integral by converting to polar coordinates. So first, we should try to draw the region D and see what it looks like. So it's described by x and y both being positive, so it's only in the first quadrant, and x squared plus y squared is in between 1 and 4. So x squared plus y squared equals 1 is the equation of the unit circle, and x squared plus y squared equals 4 is the equation of a circle of radius 2. And so the inequalities are saying it's in between these two circles and in the first quadrant, so it's exactly this region here. So this is our region D of integration. So in order to convert it to polar coordinates, we want to describe the same region, but in terms of the polar variables r and theta. So we can describe this as the radius being in between 1 and 2, since the region is in between the circles of radius 1 and 2. And theta, since it's in the first quadrant, here to the right is theta equals 0. And straight up on the y-axis is theta equals pi over 2. And of course the first quadrant is everything in between. So these are the inequalities that describe the region D in polar coordinates. Now to convert the integral. So the original integral is equal to, let's do r first, 1 to 2, theta from 0 to pi over 2. And now we need to substitute. Remember, the change to polar coordinates is that x is equal to r cosine theta. So this is r squared cosine squared theta, and y is r sine theta. So r squared sine squared theta. And remember, dx dy becomes r dr d theta. We get an extra factor of r in the differential. Okay, now let's simplify before moving on. We can factor an r squared out, and of course cosine squared plus sine squared is just 1. So this is pi over 4 r squared. Now actually, I take it back. Let's do the theta integral first. So let's actually do these in the other order. And the only reason I say that is because if you notice, there's no theta in the integrand function, so the theta integral will be very easy, so let's get it out of the way. Again, there's no theta, so everything here is a constant if we're integrating with respect to theta. So the first integral just gives us an extra factor of pi over 2. And now we're done with the first integral. Now, Let's maybe do a U-Substitution here. U is pi over 4 r squared. Then du is pi over 2 r dr. And we have r dr times pi over 2. So that's all du. So this is just cosine u du. And what are the new bounds? When r is 1, u is pi over 4. And when r is 2, u is pi. And the antiderivative of cosine is just sine. So this is just sine of u from pi over 4 to pi. And of course sine of pi is 0, and sine of pi over 4 is 1 over the square root of 2. So this is just negative 1 over the square root of 2. And that is our final answer.